Dear students, welcome to CR's digital classes. So here let us learn the concept of chi-square test for independence of attributes. So chi-square test in the previous sem also we have learned. Now the same thing here in small samples also how it goes on. Let us have a glance. So chi-square test for independence of attributes type of data whenever we have particularly, then we'll go for this chi-square test here also. So chi-square test is used to find the association between two attributes A and B under consideration. So attributes, again, if you have two attributes A and B, in such situations we'll go for chi-square to get association. So whether the two attributes under consideration are independent or not also we'll check it out. For example, whether a given medicine A is effective in curing a certain disease B or not. So example also they specified here. Some medicine we are considering A medicine, and whether it is effective in curing B or not. So such situations are there, means such type of data are there, means we'll go for chi-square test of independence. So independence attributes will have and we'll try to check its relationship or association we'll call. So such type of data whenever we have, we'll utilize our chi-square test. So one more we have whether there is any association between the intelligence of father and son. So I want to know intelligence quantity for a father and son. So father and son, it's independent, right? Whoever might be. So the independent samples like intelligence. So if you want to know, those are independent only. Like intelligence level, it's different for every person. So father and son relation we have, but their intelligence level will be based on their own thing. So those are independent relation they have, but intelligence level will be independent. So in such situations, if I want to know their intelligence level, I can utilize my chi-square test of independence, and data is attributes type of data. So exactly our chi-square test fits here. So now let us check it out how it goes on. Chi-square test formula and all, let us check it out. So under null hypothesis, the two attributes are considered independent. So let us check it out how it goes on. So under null hypothesis, the two attributes are considered independent. Yes, just now we discussed independent attributes are there. In such situations only we will go for chi-square test of independence. So here under null hypothesis also, we'll assume that two samples are independent or attributes are independent. That is, they are not associated. So they are not associated. They don't have frame any association, that we consider under null hypothesis. Now, on this assumption, the expected cell frequencies are calculated. So, whenever chi-square test of independence will consider, we'll have observed frequencies and then expected frequencies. Expected frequencies will calculate for the different cells. So, many different type of data at a time will handle. For observed data will get the expected frequencies. So that will be calculated here. Let us check it out how it goes on. So these expected frequencies are compared with observed frequencies to obtain chi-square value. So observed data will have, we'll utilize that and we'll try to get the expected frequencies. Using that, we'll get a chi-square value. So table will be in this way. Attributes type of data table will be in this way. It will be. So check it out. A attributes A1, A2, so on up to AN attributes I have, and then B type of data, B attributes are B1, B2, so on up to BM we have. So whenever such type of table, contingency table whenever we have, so we'll go for the totals. First is total columns, you have check it out. All the totals will specify B1, B2, so on up to BM, and this side totals A1, A2, so on up to AN, and overall total will be represented as capital N. Altogether same total you will get column wise, row wise, and we specify that as capital N. Now let us check it out the formulas for our chi-square test. So expected frequencies we have to obtain using the observed frequencies. Just now whatever the A1, A2 values we have checked, right? So A1, B1, this is the observed frequency for first set, first row, first column. So O11, I can say that one. So observed frequencies for first row, first column, or A attribute and B attribute. So O11 observed frequency, using that E11 expected frequency for first row and first column, let us try to obtain using the formula. So expected value of A1, B1. So A1 attribute and B1 attribute. The formula goes like this: A1 into B1 values divided by capital N. Using that values, that totals of A1 first row and first column totals divided by capital N overall total. If you do, the first value, first expected frequencies will obtain. So this becomes a formula. Similarly, let us check it out. If at all I need second attribute A2 with the combination of B1, so what how the formula goes on, let us check it out. So expectation of A2 B1 I require. So simply A2 intersection B1 intersection totals you have to consider. So A2 total into B1 total divided by overall total, that is your capital N. If you consider, you get the values for expected values for A2 B1 combinations. So in that way, entire row, consider every row from the beginning A1 B1 to the last values, that is your AN BM. You have to calculate for each and every observed frequencies. You have to calculate every expected frequencies using the same formula. Let us check it out how it frames for the last intersections, that is expected value for A1 and BM. So its intersections you have to consider its totals, AN into BM total divided by capital N. You do, you get the last value. So in this way, each and every observed frequency, like have a glance on the table, like first A1 B1, then second one, then so on up to nth term, then like that every value, every each and every row value up to the last. If you go on doing these are observed values, we'll get the expected values using our formula. So in this way, up to the last, I have framed my expected values also. So now I have in my hand observed values as well as expected values, right? So using that values, we can frame our chi-square test statistics formula. Now what is that? Let us check it out. So chi-square is equal to summation O minus E whole square by E becomes a formula. Now E is expected values. Just now whatever we have obtained here. Let us suppose some 5 I have got here. Let us suppose some 6 I have got here. And observed values already we had, right? Let us take that also, some values like observed values. O values are observed values. Some 2, 3. Now expected values I have obtained, that is 5, 6 like that. So these are the first two values. For example, I have specified here. So O and E are nothing but observed values, given data values, and E our calculated values using these particular formulas. So I have utilized that values. Now O and E are those values. Now I need, according to the chi-square formula, I need summation OI minus EI whole square by E. So that values here I am writing. So O minus E, first of all, do the subtractions of the values and then this do its squares divided by capital E. Again you do, you will get the chi-square formula. So for these two values, if you want to try, so 2 minus 5 whole square by 5 you do, you will get the first value. Like that, the second value, third value, so on up to the last value you do, you will get the summation O minus E whole square by E, which is your chi-square formula. So in this way, we do the problem whenever we have a independent attributes type of data. So this is a chi-square formula, and that follows chi-square with n1 minus 1 comma m minus 1 degrees of freedom. This is your small sample test, right? So we have degrees of freedoms also. So degrees of freedom will be n minus 1 comma m minus 1 degrees of freedom. That is we get the table values using this degrees of freedom, so that we can compare finally and we can make a decision whether to accept H0 or reject H0. Now how the decision goes on, let us have a glance on that also. So accept H0 if chi-square calculated is less than chi-square table value. So depending on level of significance and depending on degrees of freedom, will get a table value. So take that table value, now compare with the calculated value. Calculated value means just I have explained, right? Some value I'll get in the test statistic, that value compare with a chi-square table value. If those values are less than calculated value is less than, then accept H naught, otherwise reject H naught. So H naught, reject H naught when chi-square calculated value is greater than chi-square table value. So this is your decision to making whenever chi-square independent attributes we have. So this is the concept of chi-square test of independence of attributes. Independent attributes type of data whenever we have, we go for this particular formula and we'll try to get the conclusions, dragging conclusions, framing null and alternatives. So this is the concept of chi-square test for testing independence of attributes. So hope you have understood this session. See you all in the next session. Thank you.